Today we're going to talk about learning target 2, which is to be able to identify any solutions of a quadratic function from a graph or a table. So first we need to talk about what a solution to a quadratic function is. A solution to a quadratic function is really just the x-intercepts of the function, which means they happen when y equals 0. And you might also see them referred to not as solutions, but they could also be referred to as zeros, since they happen when y equals 0, or roots. So remember back in the linear function unit 2, when we talked about intercepts, and we said the x-intercept always happens when y is 0, and the y-intercept always happens when x is 0. That's why the x-intercepts of a quadratic function happen when y is 0. So on a graph, the solutions are found on the x-axis. That's where the x-intercepts are, is on the x-axis. So in this case, one solution is 6, 0, and another solution is 8, 0. Or you could write that as x equals 6 and x equals 8. This function has two real solutions because there are two x-intercepts. Some quadratic functions only have one solution, and that happens if the parabola only touches the x-axis one time. I realize this graph is a little bit difficult to see because I didn't copy very well, but if you kind of squint your eyes and look really hard, you can see that this graph is hitting the x-axis only one time right there at the point 1, 0, or you could say x equals 1, but either way there's just one solution right there. So this graph over here has two real solutions. This graph over here has one real solution because it touches one time, and then this graph over here doesn't touch at all, so we're going to say that there's no real solutions. Now the reason that I'm using the word real in here is because there are other types of solutions to quadratic functions called imaginary solutions, which you will learn about mostly in Algebra 2. So for now, just know that even though there's no real solutions, there are some imaginary solutions. So when we talk about there being no solutions, we're going to specify by saying no real solutions. This has one real solution and two real solutions. On a table, we know that the solutions, since they're the x-intercepts, that means they happen when y equals 0. And so that's easy to see on the table that the solutions are found when y equals 0. So I'm going to look down here at these tables, and I can see that y, remember the f of x is the same as y. I can see that y is 0 right here and right here, which means that this function has two real solutions on this table, and they are -3, 0 and -1, 0. And I could also write that as x equals -3 and x equals -1. Both are acceptable ways to write a solution, either as an ordered pair or by putting x equals in front of it. In this table, y is 0 right here and right here. So we have 9, 0 and 7, 0, or x equals 9 and x equals 7. In this table, they're happening right there and right there. So we have -1, 0 and +1, 0, or x equals -1 and x equals +1. Now in this table, something interesting is happening. if you were to think about where these points are, first of all, we can see that there's no zeros. Y doesn't equal 0 over here. That doesn't mean that y is never going to equal 0. That just means it doesn't equal 0 in this little section of our function that we see in the table. So what we're going to do to make sure that it's never going to equal 0 is we're going to visualize what these ordered pairs are actually doing. So I'm just going to make a rough sketch of this graph here. And I know that the point -1, 6 would be right here. And the point 0, 5 would be right here. And the point 1, 6 would be up here. So that tells me that my parabola is doing something like that. Which means that this is also going to have no real solutions, just like this one up here. It's not just that I don't see any zeros here, but they might be somewhere else on the table if I followed my table up farther or down farther. It's that there's never going to be any zeros there, because if I graph my function, you can see that this function is never going to cross or even touch the x-axis. So here I can write no real solutions. And there we go. So that is how you find the solutions of a quadratic function. You're looking for the x-intercepts, which happen when y is 0.